Good morning to all. I am Balaji Rao. Welcome to BR Max class. In last class, we completed up to exercise number 7.10 in integration chapter. Actually, we are in definite integration. In this definite integration, we completed 10 exercises. Now we entered into last exercise, that is properties of definite integration. Whatever the problems we did in exercise number 7.9, 7.10, those problems also can be done with the help of properties of determinants very easily. So, in this class, what are the things I am going to explain? You look here. Look here. What is this? Some properties of the definite integral. Okay. Look here. Total how many properties are there? Actually, they are given P naught onwards. P naught to P7. Good morning, Jagadish. Very happy to see you in the morning. 7, P7. Actually, here 0 is there. Total, these are 8 properties. Actually, total 8 properties. And you can see here in particular, integral of a to a f of x dx equal to 0 is also there. What I will do, these 8 properties plus and this one. This one is one property, total 9 properties. So, all these 9 properties, I am going to get the proofs. I am going to derive all these results in this class. Okay, so without much delay, we will begin the class. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. Okay, what is property number 1? I will prove this. Integral of a to a f of x dx equal to 0 is there now. I will prove that property number 1. I will take that as property number 1. Okay. Okay. First property. Integral of a to a f of x dx. You need to memorize all these properties, right? Integral of a to a f of x dx equal to 0. I want to prove this property. I want to prove this property, right? Okay, so it's a very simple property. What I'll do, first I'll take let without limit. I'll suppose that when I integrate integral of f of x dx, let integral of f of x dx equal to g of x plus c. You observe here in the beginning what I written, let. That means I am considering that integral of f of x dx, when I integrate a function f of x, I am getting its answer is g of x plus c. I am supposing. Now, what I need to calculate? Integral of a to a f of x dx I need to calculate. Okay, integral of a to a, and this is model number 12. I am saying this you take it as model number 12. Okay, model wise we are doing this is model number 12, properties of definite integrals. Okay, integral of a to a f of x dx. Actually, they are asking you to calculate this. Okay, as you take an integral of f of x dx is g of x plus c. In exercise number 7.9, 7.10, we did this type of problems only now. This will be what? As integral of f of x dx is g of x, as we taken like this, as a definite integral is there. Now I am going to apply the limits. Limits are from a to a. Okay, how to apply? First, in this wherever x is there I will write upper limit, minus in this wherever x is there I will write lower limit. Okay, first apply upper limit. What you will get? G of a minus lower limit. Lower limit is also g of a. See here, upper limit in place of x you write a, g of a minus. Now in this wherever x is there you write a. What you got? G of a minus g of a. G of a minus g of a is what? 0. So we proved the first result. What is that? Integral of a to a f of x dx equal to 0. You need to memorize this. This is one property, property number 1. You need to memorize these properties. In exercise number 7.11, whatever 9 properties I am going to derive now, all those properties we will use as formulas. So you need to memorize all these things. Integral of a to a f of x dx is 0. Suppose integral of 2 to 2 f of x dx is there. That is also 0. Integral of 3 to 3 f of x dx is there. That is also 0, like that. Okay. Now, properties now, right. See this one, now I am going to derive this property. Look here, property number 0 is given. I will take it as a property number 2. Okay, property number 2. What is that property? Look here, this is the property they are asking you to derive. What is that? Integral of a to b f of x dx equal to integral of a to b f of x dx equal to integral of a to b f of t dt. What you identified in these two things? Integral of a to b, this part is same. Integral of a to b, this part is same. Okay, here what is there? Function is in terms of x, we are integrating with respect to x. Here what is there? Function is in terms of t with respect, we are integrating with respect to t. So here this variable is there, x variable. In definite integration, this variable is known as dummy variable. Not only like this, I can write like this also. This is equal to integral of a to b f of y dy. I can write like this. All these three are equal. This equal to this and this equal to this. Not only this, I can write this as integral of a to b f of z dz. Like this also I can write. Okay, so here this property is one of the very useful property. We use this property in the coming properties also. So integral of a to b f of t dt. Integral of a to b f of x dx is integral of a to b f of t dt. Very good, Jagdish. We do this integration by substitution method. Okay, so I'll derive this result. For that, what I'll do, first I'll take integral of a to b f of x dx. I take an LHS part. I want to prove that this is equal to integral of a to b f of t dt. I do this by substitution method. You take x equal to t, right? Let x equal to t, right? 1 minute, let me check. Let x equal to t. Differentiate this. I said now this I am going to do this by substitution method. I take an x equal to t. You differentiate with respect to x. D by dx of x equal to d by dx of t. Okay. D by dx of x is 1, that equal to dt by dx. From this, what is dx? Dx equal to dt. And you don't forget, in last class also I said, whenever we use substitution method in definite integration, limits changes. Here, these whatever the limits are there here, these are x values. Okay. Now, when I take x equal to t, I need to find out what are the t values for respect to x values. First, I will take x values. If x equal to a, what I will do, in this integral, in place of x, I will write a. In this part, in place of x, I will write a. Put x equal to a in this. Put x equal to a in this. What you will get? You will get t equal to a, right? T equal to a. Okay. Now, in this, in place of x, you write b. What you will get? You will get t equal to b. I will write it. If x equal to b, then it tells you that t equal to b. I hope you are understanding. Here, x equal to b is there. Na? In place of x, you write b. You will get t equal to b. So, actually, for this problem, luckily, limits are not changing. You see this one, first one, second one, third one. These three things I will substitute in this question. Okay. First, I will take it. What is that question? Integral of a to b f of x dx. This is the LHS part, right? Now, I will substitute these things in this. Limits. Here, a to b is there. What I got? Limits are not changing. Limits are from a to b only. Bhuvanesh, good morning, Bhuvanesh. Integral of a to b f of x, f of x. You observe here, what is x? We take an x as t. So here, in place of x, you write t, f of t. What is dx? Look here, what is dx? In place, dx equal to dt we got now. In place of dx, I can write dt. So, you look here, we got this property. Integral of a to b f of x dx equal to integral of a to b f of t dt. Very useful result in the coming results. Actually, it is very easy, but this result we use very frequently while deriving other results. Integral of a to b f of t dt. Here, this variable is there. This variable is known as dummy variable. X, t, in place of t, you can write y, in place of t, you can write z, f of z dz like that. So total two properties you learn. You need to memorize these properties. What is first property? Look here, integral of a to a f of x dx is 0. Okay, what is second property? Integral of a to b f of x dx equal to integral of a to b f of t dt. Okay, now we'll move to third property. Third property, important property. Look here, this property I'll take. Okay, good. Now third property, property number 3. Okay, property number 3, I'll write here. This is third property. We need to prove this property. Observe this property. What is this property? Integral of a to b f of x dx equal to minus integral of b to a f of x dx. What difference you observe in this? Look here, here f of x dx is there. Here also f of x dx is there. Then what is the difference? What is the difference in this property? Here limits are from a to b. Now here limits are from b to a. You identified one thing. Here limits are from a to b. Here limits are from b to a. Whenever you interchange these limits, here a to b is there, na? A to b. If you interchange it as b to a, you need to write minus in front of it. So whenever you want to interchange the limits, you just write minus in front of the integral. Now I need to derive this result. How to derive this result? Okay, solution for this. First part, this is important. I will take integral of with the limits changes sign also. Yes, whenever we change the limits, its sign also changes. Very good. Let integral of f of x dx. Let integral of f of x dx equal to g of x plus c. I am supposing that integral of f of x dx is g of x plus c. I am supposing like this. Now what I'll do, I'll calculate LHS and I'll see what I'll get. LHS. What is LHS? LHS is integral of a to b f of x dx. Okay, that equal to, as I taken integral of f of x dx is g of x plus c. You know that in definite integration we will write it as integral of f of x dx is g of x plus c. Integral of f of x, I'll write it as g of x and then I'll apply the limits. What are the limits? A, b. Now upper limit, in this wherever x is there, there you write b. Upper limit, what you will get? G of b minus, in this wherever x is there, there you write lower limit a, g of a. G of b minus g of a. So when I calculate this LHS, I got g of b minus g of a. Now what I will do, I will calculate this RHS also. Okay, calculate RHS, take RHS. What is RHS? Minus integral of b to a f of x dx. I am taking this part. Look here, RHS part. I'll integrate. Okay, that equal to, you look here, integral of f of x dx I need. As I take an integral of f of x dx is g of x plus c. What you will get here? Minus is there in the beginning. Look here, here minus is there. That minus I'll write minus. What is integral of f of x dx? As we taken it as g of x. Limits are from where to where? Look here, limits are from b to a. So you write the limits b to a. Okay, limits b to a. Okay, apply the limits first. Upper limit, in this wherever x is there, there you write a. What you will get? G of a minus, in this wherever x is there, there you write b. That is g of b. Okay, now multiply with minus. Here minus is there, na? Multiply with minus. Then what you will get? This minus of minus is plus. So that equal to g of b minus g of a. You observe LHS. What is LHS? G of b minus g of a. You observe RHS. What is RHS? RHS is g of b minus g of a. So LHS is same as RHS or not? Yes, LHS is same as RHS. So I'll write here. Therefore, LHS equal to RHS. So what is LHS? Copy this. Okay, and this is what we got. Integral of a to b f of x dx equal to minus integral of b to a f of x dx. Total how many properties are over? 3 properties are over. You try to memorize these properties. What is first property? What is first property? Integral of a to a f of x dx is 0. What is second property? Second property is integral of a to b f of x dx equal to integral of a to b f of t dt. That is about dummy variable. What is third property? Integral of a to b f of x dx equal to minus integral of b to a f of x dx. When we interchange the limits, we need to change of the integral. Here minus, here plus is there, no? So here we need to write minus. I hope you are all understanding. Successfully we completed 3 properties out of 9 properties. Good, good. Now next fourth property. Look here, what is this fourth property? Which one is over? Just now we completed this. This we already done in the beginning. Now we need to prove this property. Okay. Integral of a to b f of x dx equal to integral of a to c f of x dx plus integral of c to b f of x dx. Okay. I need to prove that property now. Right. Paste that. Good. This is property number 4. Okay. This is property number 4. What is this property? You observe this property. Integral of a to b f of x dx. Observe this property. Integral of a to b f of x dx is integral of a to c f of x dx plus integral of c to b f of x dx. Here you need to observe that this closed interval ab, this is closed interval ab. In the c value is in between a and b. A is less than, c is less than b in the property. Okay, the c value is in between a and b. So integral of a to b f of x dx can be written as integral of a to c f of x dx plus integral of c to b f of x dx. Okay, how to prove this result? As usual, first I will take integral of f of x dx as g of x plus c. I'll take that step in the solution. I want to derive this result. In the solution, I'll take here f of x dx is there, integral of f of x dx, I'll take it as g of x plus c. Okay, now I'll evaluate this LHS. What is LHS? LHS is integral of a to b f of x dx. Okay, what is integral of f of x dx? As I taken integral of f of x dx as g of x, what you will get here? Here you will get g of x, limits are from a to b. First apply the upper limit, you will get g of b minus, now you apply the lower limit, g of a. So LHS I calculated, I got g of b minus g of a. Now what I'll do? I'll calculate RHS also. Okay, RHS I need to calculate. What is RHS? Integral of a to c f of x dx. Okay, plus integral of c to b f of x dx. I taken RHS. Now I'll evaluate this RHS. As I taken integral of f of x dx is g of x plus c. What is integral of f of x dx? This will become g of x, limits are from a to c plus as you know, integral of f of x dx is g of x. This will become g of x, limits are from c to b. I hope you are understanding. For this, limits are from a to c. For this, limits are from c to b. Okay, here apply the upper limit minus lower limit. What you will get? This will become g of c minus g of a plus apply the limits for this. What you will get? G of b minus g of c. G of b minus g of c. Look here, anything will get cancelled. Look here, plus g of c minus g of c will get cancelled. Right? What is remaining? G of b plus g of b minus g of a. So whatever remaining is there, that I'll write. Whatever remaining, that is 1 minute. That is g of b minus g of a. Look here, what is LHS? LHS is g of b minus g of a. What is RHS? RHS is, look here, g of b minus g of a. Right? Is LHS is same as RHS? Yes, LHS is same as RHS. So what I can say? Sir, is there any limitation for writing like RHS or not? The C value must be must be in between A and B. That's it. Other than that, no limitations are there. Okay. So LHS is same as RHS. So I'll write here. Therefore LHS equal to RHS. So what is the result you learn? Property number 4. What is this property? Integral of a to b f of x dx. Whenever you saw a definite integral like this, and you know that there is a c value in the close in between a and b, there is in closed interval a comma b, then this can be written as integral of a to c f of x dx plus integral of c to b f of x dx. I hope you are understanding. This is property number 4. Right? So total 9 properties are there. We completed 4 properties. Very good. Now we'll move to this 5th property. right, look here, this particular case of P3, right, this one I'll take. In last exercise, we learned how to calculate definite integration by using substitution method. Okay, this is property number 5, right? Yes, this is property number 5. Property number 5. Okay, integral of a to b f of x dx equal to integral of a to b f of a plus b minus x dx. One of the very useful result. This derivation is very easy. I'll do this derivation of this result by substitution method. In substitution method, first I'll take RHS. I'll take this RHS. Okay. Derivation. Take RHS. What is RHS? RHS is like this. First, I take RHS and I'll prove LHS. F of a plus b minus x dx. Okay, I need to evaluate this. As I said, I am going to do this by substitution method. What I'll do, I'll take a plus b minus x as t. Okay, you take let a plus b minus x as t. Okay, now what you do, you differentiate this with respect to x on both sides, right? Differentiate this with respect to x on both sides. D by dx of a plus b minus x equal to d by dx of t. Okay, derivative of a. What is derivative of this? Derivative of a plus derivative of b minus derivative of x. Derivative of a is constant 0. Derivative of b constant 0. So derivative of x is 1. So if you differentiate this, you will get minus 1 equal to dt by dx. What I want from this? I want dx. What is dx? Dx equal to minus dt. Okay, this is a definite integration by substitution method. We learned in last exercise also, whenever we use substitution method in definite integration, limits changes. That point, you don't forget that point. So here these are the limits, whatever the limits they given, that is for x. X equal to a, x equal to b. See, first I taken this a. These are the limits for x. You put x equal to a in this x equal to a, you substitute here, put x equal to a. What you will get? Plus a minus a will get cancelled. You will get t equal to b. I hope you are understanding. So in this, in place of x, if I write a, these things will get cancelled. You will get t equal to b. I will write here, when x equal to a, t equal to b. Now lower limit you observe, x equal to b. In this where x is there, there you write b. In place of x, if I write b, this plus b minus b will get cancelled. You will get t equal to a. It can be understood easily. T equal to a. Now three things are there. This is the first one. I'll take I taken a plus b minus x as t. First point, second point, third point. These three things I'll substitute in this question. Okay, substitute. What you will get? First point, integral of limits changes na a to b changes to b to a. Okay, I'll write here limits are b to a. F of, look here, a plus b minus x, we taken it as t na. So in place of a plus b minus x, I'll write t. Okay, in place of a plus b minus x, I'll write t into dx. What is dx? Dx is minus dt. Dx is minus dt. So in this question, here dx is there na. In place of dx, I need to write minus dt. As minus is constant, I'll write outside this integral, right? That minus I'll write here minus dt. I hope you are understanding. See, if you want to interchange the limits, you can interchange. Whenever you interchange the limits, you need to change the sign of the integral. Here minus sign is there na. If you want to interchange these limits, you interchange. Here b to a is there na. If you want, you can write it as a to b. We learned that property, right? So whenever you interchange the limits, here b to a is there, I written as a to b. When you interchange the limits, you need to change the sign of the integral. Here minus is there na. So here plus will come. Okay. So that plus no need to write. Into f of t dt. See, second property, this is dummy variable, right? So you know this property. What property? Integral of a to b f of x dx is same as integral of a to b f of t dt. You know this. Now we have this one, integral of a to b f of t dt. That can be written as integral of a to b f of x dx, right? So I'll write it, that equal to integral of a to b f of x dx. You can observe, one minute, you can observe that we got LHS. What is LHS in this? Integral of a to b f of x dx. Look here what I got. Integral of a to b f of x dx. So this is LHS. I started with RHS. I got LHS. So what I can conclude here? I can say that therefore LHS equal to RHS. Okay. So here the point is right, what we proved? We proved this one. Integral of a to b f of x dx. Integral of a to b f of x dx is same as integral of a to b f of a plus b minus x dx. Actually, how we use this result? In the question, they will be like this. Question will be like this. Integral of a to b f of x dx. In the given function, wherever x is there, in place of x, you can write a plus b minus x dx. For example, the question is like this. Integral of pi by 3 to pi by 6 sin x dx is there. Okay. If you want to use this property, how to use this property? We will write like this. Integral of a to b. In this function, wherever x is there, I will write a plus b minus x. A plus b is what actually? A plus b is sum of limits. Okay, you look here, sum of limits, pi by 3 is 60, pi by 6 is 30. Sum of these limits is what? Pi by 3 plus pi by 6 is what? Pi by 3 plus pi by 6 is pi by 2. So this can be written as sine of pi by 2 minus x dx. We can write like this. Okay, while doing problems, exercise problems, you will come to know all those things clearly. But for time being, what you need to know? You need to know that this is one of the important result. Integral of a to b f of x dx is integral of a to b f of a plus b minus x dx. I hope you are all understanding, right? Good. So total 5 properties we completed. Another 4 properties are there. Especially last 2 properties are very important. Now you see this one, this property, integral of 0 to a f of x dx is integral of 0 to a f of a minus x dx. This property, property number 3, property number 4, both are same only. You look here, in place of x, sum of limits minus x is there, a plus b minus x. You look here, sum of limit 0 plus a is what? 0 plus a is a only, a minus x. That's why they specially mentioned. Note that P4 is a particular case of P3. Particular case means here lower limit a to a is there, here lower limit 0 is there, that's it. Actually both the properties are same only. Okay, however, I am going to prove this property, right? Property number 6. Okay, property number 6. Property number 6. Property number 6. This property derivation, yes sir, understand. Very good, Jagdish. This property derivation, last property derivation, same procedure. See what I did here. I taken RHS and I proceeded further in 5th property. In 6th property also we will follow the same procedure. I am going to do this by substitution method only. First I will take RHS. What is RHS? Integral of 0 to a f of a minus x dx. Okay, I taken RHS. I do this by substitution method. In substitution method we will take a minus x equal to t. Okay, let a minus x equal to t. Now what to do? I need to differentiate this. D by dx of a minus x equal to d by dx of t. Okay, right. Derivative of a minus x. Derivative of a is 0. Derivative of x is 1. 0 minus 1. 0 minus 1 is what? Minus 1. So derivative of a minus x is minus 1 equal to dt by dx. From this, what is dx? Dx is minus dt. That can be understood easily. Now this is definite integration by substitution. In last class we discussed that we learned that whenever we use substitution method in definite integration, limits changes. Don't forget that, right? Change the limits. If x equal to 0, look here, lower, these are the x values. If x equal to 0, what is t? What is t? Look here, this x value equal to 0, you substitute in this. In place of x, if I write 0, a minus 0 is a only. So that means t is a. T equal to a. Okay. If x equal to upper limit, what is upper limit? A. If x equal to a, in this, in place of x, you write a. A minus a is what? A minus a is 0, right? So what you will get? T is 0. I hope you are understanding. Okay, now see, this is the first point. Okay, second point, third point. These three things I'll substitute in this question. Let's see what changes will happen. That equal to integral of, here limits are 0 to a, na? Limits changes from a to 0. Okay, here 0 to a, this is a to 0. Observe here, this is 0 to a, here a to 0. Lower limit is a, upper limit is 0. Okay, a to 0. In the question, f of a minus x is there here. A minus x. A minus x is what? A minus x is t. F of t into dx is there. What is dx we got here? Dx we got it as minus dt. So in place of dx, I'll write minus dt. As minus is constant, I'll write here first. Minus dt. Okay. You know that if you want to interchange the limits, you can interchange. Here a to is 0 is there. Na? I want to write it as 0 to a. Whenever you interchange the limits in definite integral, integral sign also changes. This is one of the property we learned in the beginning. So I want to write this integral limits are from 0 to a. As you interchange these limits, you change the sign. Here minus is there. So what it will become? It will become plus f of t dt. You can observe here f of t dt, dummy variable we got here. Integral of 0 to a f of t dt can be written as, this can be written as, we learned this property now. 0 to a f of x dx. Right, so I'll write here, as it is a dummy variable, I can write it as 0 to a f of x dx. I hope you are understanding this property. We have this property. Okay, so total 6 properties completed out of 9 properties. Okay, next another 2 properties are there. Okay, let's see what are those 2 properties. Good. So I just quickly recall what are the properties we learned. What is the first property? Integral of a to a f of x dx is 0. What is the second property? Integral of a to b f of x dx is integral of a to b f of t dt. This is dummy variable property. Okay. Next, the third property is what? Integral of a to b f of x dx equal to minus integral of a to b f of x dx. I just interchange the limit so that integral sign also changes. Next, third property is what? Integral of a to b f of x dx can be written as integral of a to c f of x dx plus integral of c to b f of x dx. Okay. What is the fourth property? What is the fifth property we proved? Integral of a to b f of x dx is same as integral of a to b f of a plus b minus x dx. What is the sixth property? Integral of 0 to a f of x dx is integral of 0 to a f of a minus x dx. Okay. Now, you see this property. You see this property. I am going to prove this property. No, I'll do one thing. Actually, this property comes directly. I'll do. I just want to derive this property directly. I want to do this property directly. Okay. So good to go. 1 minute. Last 2 properties. Okay, this is property number 7. Okay, this is property number 7. Property number 7. Some problems are there here. First, try to understand what is this property. Look here, integral of 0 to 2a f of x dx. 0 to 2a f of x dx. This is little difficult. Please try to understand. Integral of 0 to 2a f of x dx can be written as 2 times of integral of 0 to a f of x dx. This is what I want to prove. This equal to this. When f of 2a minus x is f of x. When f of 2a minus x is f of x, in that case, integral of 0 to 2a f of x dx will be 2 times of integral of 0 to a f of x dx. Okay. So second property is integral. In this second one is integral of 0 to 2a f of x dx is 0. When they are saying that when f of 2a minus x is minus f of x, right? So this is the property I am going to derive now. Okay, to derive this, first I will take this LHS part. What is this LHS part? Integral of 0 to 2a f of x dx. Okay, right, LHS part, integral of 0 to 2a f of x dx. I taken this part. Okay, In between 0 and 2a, a is there. If I take the closed interval 0 to 2a, in between the closed interval 0 to 2a, a is there. Yes, of course, a will be there. So you know that property, integral of a to b f of x dx can be written as integral of a to c f of x dx plus integral of c to b f of x dx. That property is there now. So this can be written as integral of 0 to a f of x dx plus integral of a to 2a f of x dx. Look here, this is c. See here, this is c, like a to c f of x dx plus c to b f of x dx. I hope you understand. This is one of the property that we learned, right? Good. Now further how to simplify this? I do simplification in this second integral only. I'll do the simplification in second integral only. How to do that? I'll write here in second integral. Whatever the changes I am doing, that is in second integral. Second integral means whatever I written here, it means that all the changes will happen here only. This integral I'll change by substitution method. In second integral, I'll take x equal to, in place of x, I'll write 2a minus t. Let x equal to 2a minus t. Okay. So here, how to remember that x equal to 2a minus t? You look here, 2a minus x is there now in this property. That's why. So here, to do this integral, what I'll do, let x equal to 2a minus t. Here this x is there now. I am taking x equal to 2a minus t. Or else you can take t, 2a minus x equal to t also you can take. Good, very good. So here what I'll do, I'll differentiate this with respect to x. dy dx of x equal to dy dx of 2a minus t. Okay. So what you will get, derivative of x with respect to x is 1 equal to dy dx of 2a, as 2a is constant, derivative of constant is 0, equal to minus dt by dx. Derivative of t with respect to x is dt by dx. From this, what is dx? Dx equal to minus dt. Okay, this is the one point. Now you know that whenever you use the substitution method in definite integration, limits changes, correct? So how the limits changes, I'll write. See, whatever I am doing, they are all for in second integral only. That is what I written in second integral, right? What I'll do now, if x equal to a, look here, x equal to a, then what is the t? What is t? In this, in place of x, you write a, okay, x equal to, I'll write here to understand, x equal to 2a minus t I taken now. What is t from this? T is 2a minus x. Look here, x equal to 2a minus t taken. From this, what is t? You take this t to the left hand side. T equal to 2a minus x. You put x equal to a in this. You put x equal to a in this. If you put x equal to a, t equal to a, right? This is t equal to a. Okay. Now lower limit is over. Now upper limit. What is upper limit here? Upper limit is 2a. If x equal to 2a, put x equal to 2a in this. If you put x equal to 2a, 2a minus 2a is 0, right? T equal to 0, right? T equal to 0. I hope you are understanding, right? So now three things. 1, 2, 3. These three things I'll change in second integral only. X equal to a, t equal to a. No man. No, we are doing this in second, Jagadish, we are changing only in second integral, not in first integral. Okay, in second integral, see, that's why I specified. Whatever the changes I am doing, that changes are in second integral only, not in first integral. Okay, here this is first integral, this is second integral. I am doing changes here only. Okay. Priyadarshini, very good. Very good. So many people are actively participating. Very happy for that. So, start writing. This is the part. This is the part as usual. Okay. I'll write that part as usual. This part is as usual, first part. Now, look here. From here onwards, plus limits here, a to 2a is there. Na? Here limits are from a to 0. Limits are from integral of integral of a to 0, integral of a to 0. By considering this, I am saying a to 0, okay, a to 0, okay. In this f of what is x? I taken x equal to 2a minus t. You need to know this. You need to memorize this. For this proof, we will take x equal to 2a minus t. So in this, in place of x, I'll write 2a minus t. Right? F of 2a minus t into dx. Look here, what is dx? We got dx as minus dt. Right? Dx as minus dt. So here minus I'll write outside the integral. This plus will changes to minus. I hope you are understanding. Actually this plus dx na, as dx is minus dt, I written minus dt. I hope you understand this. Further we'll simplify this. The integral of 0 to a f of x dx. Here I want to interchange the limits. A to 0 is there na, I want to write 0 to a. If you want to interchange the limits, you write just change the sign of the integral. Here minus is there na, minus will become plus. So here integral of a to 0 is there na, that will become 0 to a. As you interchanged a to 0 as 0 to a, its sign changes. This minus will become plus f of 2a minus t dt. You can look here dummy variable. This is in terms of t. You can write same thing in terms of x because we learned this property. Integral of a to b f of x dx is same as integral of a to b f of t dt. We learned this property now. So what it can be written as, look here, this can be written as integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. This is completely in terms of t. As t is dummy variable, I can write it as integral of 0 to a f of 2a minus x dx. Left hand side part, what is there? Integral of 0 to 2a f of x dx. So this is the main thing to proceed further. You see what is there here? Integral of 0 to 2a f of x dx as integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. This is also one of the property. We can use it as a formula also. I hope you are understanding, right? You take it as one. Further, how to do this problem? Okay, so here you see here two cases are there actually in the question. One is f of 2a minus x equal to f of x. Another one is f of 2a minus x equal to minus f of x. So first I'll try to prove this part. What is this part? I need to prove that integral of 0 to 2a f of x dx is 2 times of integral of 0 to a f of x dx if f of 2a minus x is f of x. Okay, I divide this further into two cases. First case, f of 2a minus x equal to f of x. Okay, I'll do this further, this problem. Actually, I have this one. Okay, I will take here case 1. What is case 1? If f of 2a minus x, f of 2a minus x equal to f of x. This is there in the question only. Look here, f of 2a minus x equal to f of x. Okay, then what will happen? So here this equation 1 is there, na, that you take equation 1, that you take copy and paste here. This is the result we got. Look here, this is the result we got. What the result is there? Same thing I written here. Now this case is what? This is the case f of 2a minus x is same as f of x. So in this, where is 2a minus x? Look here, f of 2a minus x is there here. So in this result here f of 2a minus x is there. In place of f of 2a minus x, I can write f of x because this is that case. Okay, that equal to integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x is f of x in this case. So in place of f of 2a minus x, you write f of x dx. You look here please, 0 to a f of x dx, 0 to a f of x dx. Same picture. What is there here? Same thing is there. Apple plus apple is 2 apple, right? X plus x is 2x na. So what if we add these two things? If we add these two things, what you will get? 2 times of integral of 0 to a f of x dx. So what I got? Here? I got that integral of 0 to 2a f of x dx. Integral of 0 to 2a f of x dx is 2 times of integral of 0 to a f of x dx whenever f of 2a minus x is f of x. I hope you are all understanding. Whenever f of 2a minus x equal to f of x, then integral of 0 to 2a f of x dx is 2 times of integral of 0 to a f of x dx. This is what they are asking to prove. Look here, 2 times of integral of 0 to a f of x dx. Look here what we got, 2 times of integral of 0 to a f of x dx. Okay, so in this case 1 is over. Now case 2. What is case 2? Whenever f of 2a minus x is f of x, then we need to show that this value is 0. Okay, so I'll take it as case 2. Okay, case 2. What is this case 2? This case 2 is f of 2a minus x is minus f of x. Look here what they given. This they'll give in the question only, f of 2a minus x equal to minus f of x. Then I need to prove that this answer is 0. Okay, no problem, right? So here, no, not this one. I don't want this one. Okay, I want this one, equation 1. Okay, look here, I want this equation 1. Copy this. Okay, I got this from equation 1. Okay, I got this from equation 1. What is this case? Integral of 0 to a f of x dx plus this case is here f of 2a minus x is there. Now, wherever f of 2a minus x is there, there you write minus f of x. Wherever f of 2a minus x is there, there you write minus f of x. Okay. So, this is integral of 0 to a f of 2a minus x is what? Minus f of x. Now, that minus I will write here. Plus of minus is minus. Plus of minus is minus 0 to a. Very good, Jagdish. F of 2a minus x is minus f of x dx. Look here, you do not confuse with this minus. Here, f of 2a minus x is minus f of x. Now, this f of 2a minus x is minus f of x. Now, I multiplied this plus minus so that it will become minus. Now, look here, 0 to a f of x dx, 0 to a f of x dx, like x minus x, right? X minus x is 0 now. So, what you will get here? This is 0. So, integral of 0 to a f of x dx, integral of a to 0 to 2a f of x dx is 0. So, we proved here second one, we proved this second result, right? So, 1 minute, I will take copy this. Okay, right, come here. Finally, what I proved this. Okay, what is this result? Integral of 0 to 2a f of x dx is 2 times of integral of 0 to a f of x dx when f of 2a minus x is f of x. Integral of 0 to 2a f of x dx is 0 when f of 2a minus x is minus f of x. I hope you are understanding. If you understand this video, please drop a like for this video and share this video with your friends. Okay. Just one more result is there. Before that, I'll take small water break, just 30 seconds. So, finally, we came to the last property, right? Last property. What is the last property? Look here, this is the last property. This is the last property. 1 minute, I want to, oh, sorry. Okay. Copy this. Total how many properties completed till now? 7 properties completed. Okay, this is 8th property. This is 8th property. Okay, first thing we will try to understand what is this property. What is this property? Look here, integral of minus a to a f of x dx. Integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx. 2 times of integral of 0 to a f of x dx. Okay, when f of minus x is f of x. We know that f of minus x is f of x means the function is known as even function. Very simple. Integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx when the function is even function. What is the definition of even function? When f of minus x is f of x, then we call it as a even function. Second one is integral of minus a to a f of x dx is 0. Integral of minus a to a f of x dx, this value is 0 when the given function is there, if that function is odd function. What is the definition of odd function? F of minus x is minus f of x, then we call it as a odd function, right? Let's derive this result. This is very easy result only. First, we'll take integral of minus a to a f of x dx. I'll simplify this like last derivation. You know that. What do you know? You know that integral of a to b f of x dx. So, in this case, x equal to minus t. Yes, correct. So, what I will do here, first, you know this property, integral of a to b f of x dx can be written as integral of a to c f of x dx plus integral of c to b f of x dx. Okay, so this can be written as in between minus a and plus a, 0 is there. In between minus a and plus a, 0 is there. Yes, is there in closed interval minus a to a, 0 is there. So, this can be written as minus a to 0 f of x dx, okay, plus integral of 0 to a f of x dx. Okay, clear. So, what I will do, whatever changes I will make, here I will make the changes in first integral only. In last result, we made the changes in second integral. Now, we will make the changes in first integral. In first integral, I will write here, in first integral. In first integral. Okay, in first integral, what I will do, let x equal to minus t. You need to memorize this. In case if you forgot to memorize this, just simply leave this problem and go for next problem. No other option is there, right? You need to memorize this. To proceed further in this problem, you need to memorize that x equal to minus t. When I take x equal to minus t, then I can prove these results very easily. Okay, now you differentiate this with respect to x on both sides. D by dx of x equal to d by dx of minus t. Okay, derivative of x with respect to x is 1. Here minus is constant, so take it outside. What it will become? Minus dt by dx. From this, what is dx? Dx equal to minus dt. In last exercise, we done definite integration by substitution. Whenever we use substitution method in definite integration, limits changes. You don't forget that, limits changes. Okay, if x equal to first integral, what is there here? Minus a is there. If x equal to minus a, then what is t? So this x equal to minus a is there, you write here in place of x, you write minus a. In this equation, in place of x, you write minus a. Minus a equal to minus t. Minus minus will get cancelled. You will get t equal to a. I hope you are understanding. In this, in place of x, if you write minus a, minus minus will get cancelled. You will get t equal to a. That I will write t equal to a. Now, what is the upper limit? I am doing changes only in this first integral. Okay, upper limit is 0. If x equal to 0, then what is t? In this, wherever, 1 minute please. In this, wherever x is there, there you write 0. 0 equal to minus t, that means t equal to 0, right? T equal to 0, right? Now, 3 things. 1, 2, 3. These 3 things you substitute in this first integral only. First integral only. Okay. So here, what is this part? This part I'll take first. Copy, paste. Okay. Equal to. Now, what are the changes? What are the changes we need to make in first integral? Here, minus a to 0 is there. Na? Here, what I got? I got a to 0, right? Integral of a to 0 f of what is x? We taken x equal to minus t. So in this in place of x, you write minus t. F of minus t. Okay. What is dx? Look here, dx is minus dt. Minus is constant, so I'll write that minus here. Minus dt. Okay. Plus. Now this one is second part is as usual. This part is as usual. Okay. I'll write that second part is as usual. So what happened? You observe, this is as it is, this is also as it is. I made changes in this first integral only, then I got like this. Now here this is a to 0. I want to interchange the limits. I want to interchange the limits. A to 0 is there now. I want to write 0 to a. You learn the property, whenever you interchange the limits in definite integration, you need to change the sign of the integral. Here minus is there now, that you need to write it as plus, right? Plus integral of 0 to a f of minus t dt plus integral of 0 to a f of x dx. Okay, f of x dx. You observe here, this is a function is in terms of t, we are integrating with respect to t. This is definite integration. So here t is dummy variable. So what I can write, you know this property. What property? Integral of a to b f of x dx is same as integral of a to b f of t dt. Right? I'll write it. So that equal to, so what I can write here, integral of 0 to a f of, in place of t I can write x, because we learned this property, second property, 0 to a f of x dx. So integral of minus a to a f of x dx. Integral of minus a to a f of x dx is integral of 0 to a f of minus x dx plus integral of 0 to a f of x dx. This you can take it as a formula. Further, we will proceed from this only. I'll take this as equation number 1. Okay. So here in this two cases are there. You look here. One is when the function is even function. Even function means f of minus x is f of x. I'll write here this case also I'll take. Okay. To proceed this problem further, this is the one. This is the one I have. Now I'll write it as a case 1. What is case 1? Case 1 is if f is even function. F is even function. Even function means what? When we say function is even function, when f of minus x is f of x, then we say that the function is even function. So this is the case, f of minus x is f of x. Okay, let me take this what we got from equation 1, that I'll copy, I'll paste here. This is what actually we have. Now in this formula, in place of f of minus x, I can write f of x. In this formula, in place of f of minus x, I can write f of x. Look here. Here f of minus x is there. In place of f of minus x, I can write f of x. Okay, that equal to integral of 0 to a. What is f of minus x? F of minus x is f of x. F of x dx plus integral of 0 to a f of x dx. Look here, these two things are same. This two things are same, like x plus x. X plus x is 2x now. So what you will get here? This equal to 2 times of integral of 0 to a f of x dx. So this side what is there? Integral of minus a to a f of x dx equal to 2 times of integral of 0 to a f of x dx. First part is over actually. Look here, integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx. Look here, integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx. When the function is even function, that part is completed. Now case 2. What is case 2? When the function is odd function. Look here, when the function is odd function means f of minus x is f of minus f of x. Okay, case 2. I'll write here case 2. Okay, case 2. This is case 2. Case 2. Okay, what is case 2? What is this one is there? We have this equation 1. We derived this equation 1. I'll take this one. Okay, so this is from equation 1. From equation 1 we got like this. Okay, from equation 1 we got like this. In this, wherever f of minus x is there, I can write minus f of x, because this is the case of odd function. Odd function means f of minus x is minus f of x. So in this formula, integral of 0 to a, in place of f of minus x, I'll write minus f of x dx plus integral of 0 to a f of x dx. You look here, this both are same but having opposite sign. This is having negative sign, this is having plus sign. That means these two will get cancelled. It will become 0. So integral of minus a to a f of x dx is 0. So finally I'll conclude. So what are the things we proved actually in this? We proved that therefore integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx when f of x is even. F of x is even function means f of minus x is f of x, f of minus x is f of x, and same thing will become 0. That means integral of minus a to a f of x dx is 0 if the function is odd function. F of x is odd function. Odd function means f of minus x equal to minus f of x. Okay, right. So we derived all 8 results. How much time it taken? Oh, it's 1 hour. Right, good. Jagdish, are you there? Are you there, Jagdish? Okay, you see these properties. Now it was become so interesting topic, sir. Thank you. Right. Actually, Jagdish, you are a very good student. I am observing you now. Whatever the way you are answering before I'll do the problem you are doing, that is a good sign that you are a good student. So the point is we need to memorize these formulas. Okay. So next class is all about exercise number 7.11. I'll do that in 2 classes. In one class, I'll do half of exercise number 7.11. In next class, I'll complete. So by tomorrow morning, I can complete this complete integration chapter. And miscellaneous exercise is also there. That exercise also will complete. Right? I hope you are understanding this class. For the next class, if you want to understand the next class, you must be thorough with all these properties. Right? Thanks for watching this video. Have a great day. Bye-bye.